Hello, and welcome to Astronomy 100. In this video, what we're going to do is talk about what happens after a star has died. We've spent quite a few videos talking about the process of stellar evolution that leads up to the ultimate death of a star. But what we need to do now is talk about what happens to the core of that star following the death of the star. And there's some interesting things that can happen related to physics, of course, but we'll talk about what gravity, essentially gravity, does to the core of the star, and some interesting things will come from that. So what we're ready to do now is finish our list. What do stars become after their quote-unquote death? So let's go ahead and get started. Now, in the previous video, we talked about this event that occurs for the highest mass stars. This is what we call a supernova, where the envelope and part of the core of the star explodes out into space. And the core, the majority of the core itself, survives this event, and we'll talk more about what it becomes afterwards. But to walk us down that path, I want to use an example, one of the more famous examples of a supernova occurring in at least relatively modern history. It was July of the year 1054 AD when the observers of the sky on the Earth here, we wouldn't really quite call them astronomers yet, but at least sky watchers in the year 1054 witnessed something occur near the constellation of Taurus. Technically it is in Taurus, but it's up near the outer part, the edge of the constellation of Taurus, Taurus the bull. Now in Taurus, this is the face of the bull, and its two long horns come off the top of its head like this. Now in July of 1054, overnight, there was the brightening of some particular object. And it seemed as if this object came out of nowhere. Normally there was nothing there that would have been seen, but then overnight something very, very bright appeared in this spot in the sky. And it was actually the Chinese astronomers that were really good at recording the events that they were seeing in the sky. In the year 1054, this is still about the Dark Ages, not quite transitioning to the Middle Ages. So most of Europe was not really interested in astronomy, but there were Chinese astronomers that were doing a very good job of observing the sky and recording what they saw. And they recorded this object that became very bright in the sky. Now, they of course didn't know what it was, but they gave it a nickname. They called it the guest star. And the idea is, like a guest that shows up, stays for a while, and then leaves, this was an object that became very, very bright in the sky, and then over a period of time, it faded completely from view. So it was like a guest that came and then went. So it was called the guest star. And for the centuries following this, there wasn't much talk of it. It was some strange occurrence that occurred that was recorded, or at least talked about, and then ignored and eventually forgotten. Well, many, many centuries later, there was an astronomer that was looking through the sky with his now telescope. Telescopes had been invented by this point. And he noticed that there was a very odd-shaped cloud in the constellation of Taurus. And the cloud itself has a funny shape to it, just a little bit different than usual. And today we give a catalog number to this cloud. It is called M1. It is the first item on the Messier catalog list. Now the astronomer who discovered this odd-shaped cloud nicknamed it the Crab Nebula. And the reason why it's called that is because if you look at this part right here, it looks a little bit like the claw of a crab. So this little gap right here is like the opening between the pincher. So this part comes down on this part when you close the two pieces together. So it looks like the claw of a crab, or the Crab Nebula. Now, when he discovers this cloud in the sky, he thinks it's an interesting looking cloud, and he talks about it and he draws pictures of it, and again, it's just sort of forgotten through history. But a few centuries later, more modern astronomers sort of put two and two together. And what they realized was this cloud was located precisely in the same place in the sky where the Chinese astronomers had made a reference to the event that occurred in the year 1054. So what they realized is what the Chinese astronomers had witnessed was a supernova. And what you're now looking at is almost a thousand years later, this is the supernova remnant. So careful observations have shown that this cloud is physically getting bigger and bigger as every moment goes by. So this cloud is expanding outward from this supernova that occurred 1,000 years ago. With modern telescopes, they looked very deeply inside of this cloud, and what they discovered is a particular object. So right at the tip of this arrow, this little white dot turns out to be the core of the star that ultimately exploded. So this is the collapsed core of the star that went supernova 1,000 years ago. So the cloud itself is called the Crab Nebula, and the object inside of it has a slightly different name that we'll talk about in just a minute. Now the question is, what happens to the core that suffers this gravitational collapse? What does it become after the collapse has occurred? So to understand that, let me show you the concept. Remember that the core, right before the supernova occurs, the core is made out of iron. Iron has lots of protons, 26 protons, lots of neutrons, and of course electrons mixed in. But what has happened is gravity has collapsed this iron core. And when that occurs, the force of gravity squeezes and crushes all of the protons and the neutrons and the electrons, crushing them closer together, tightly packed. And what will happen is the protons and the electrons that are in this mixture are forced to become one thing. So a proton and an electron are literally mashed together. And according to the physics that we call quantum mechanics, when a proton and an electron are forced into one single object, they turn into a neutron. So a proton combined with an electron becomes a neutron. So what happens is this iron core has all of its protons and its electrons crushed together due to gravity, and we end up with a sphere of nothing but neutrons. And we call this a neutron star. So the core, the iron core that has collapsed and the supernova has occurred, and the iron core, due to gravity, has been crushed down to something called a neutron star. Think of an object that is made of nothing but neutrons, that gravity is crushing and holding together as this giant ball of neutrons. Now remember, gravity has forced this to happen. So let's talk about how really small a neutron star is. In a previous video, we talked about white dwarfs. And as a comparison, what I showed you was the size of a typical white dwarf compared to the Earth. And just as a reminder, remember that a white dwarf is the remnant core of an intermediate mass star that has ended its life through a planetary nebula. So an example is the future sun is going to become a white dwarf, or at least its core is, as the sun ends its evolutionary sequence. Now, a neutron star is the core of a high mass star that gravity has crushed into something very, very small. But because a high mass star is higher in mass, therefore more gravity, gravity crushes the core to something very, very small. Look at the size of this neutron star compared to a white dwarf, compared to the size of the Earth. Now, the amazing thing about this is the amount of material packed into this tiny little size is about somewhere in the neighborhood of 2 to 2.5 times all of this material put together. So imagine taking two of these, crushing them down to something this small. So the force of gravity under the right conditions can become incredibly powerful. And this incredibly powerful gravity will shrink these objects down to something very, very small. So a neutron star ends up being the ultimate fate of, in some cases, what a high mass star will produce once the core collapses down due to gravity, the supernova occurs, and that leaves behind this neutron star. Now, the concept of a neutron star is one it's just amazing to think of, a single object made of nothing but neutrons. And it turns out that a neutron star is the densest material that you could ever possibly have in our universe. In other words, you cannot get to densities that are anything higher than what the neutron star density happens to be. And that's simply because when you have a ball of nothing but neutrons, what's going to happen is that you have essentially the density of the nucleus of an atom. And the nuclei of atoms are the densest materials that you could ever possibly have. And so if you were to take, let's say, an imaginary teaspoon, and you could go up to a neutron star and survive its gravity, that's a whole nother story. But if you could take that little tiny teaspoon and scoop up just a little scoop of the neutron material, inside of that teaspoon, you would have the equivalent of millions of tons of material that is just packed down into that little tiny volume. So it is just an enormous amount of material that has been crushed into something very, very small. And the continual force of gravity is keeping it as that very, very small object. There are some obvious questions that now come from this. One of those questions is, well, first of all, why doesn't it crush to something even smaller? And we'll get to that eventually. Another question is, how do we know something like this even exists? If the object itself is very, very small, and these are very big distances away from us, how do we find something like a neutron star? A typical neutron star will be about the size of a major city. So imagine an object that might only be 10 or 12 miles across at a distance of maybe 500 light years. How do you find something that small? Well, it turns out there are ways to find them. And the story of how we found the very first neutron star is quite an amazing one. But we'll get to that into the next video. We're running just a little short of time to include it in this one. We'll include it in the next one. I hope you'll join me.